Welcome to session 10. We have seen all the digestive glands till now. Let's have some quick look of their compositions. So it includes, we have discussed the salivary juice. Next, the gastric juice. Next, the pancreatic juice. Next, the bile juice, and the intestinal juice or the saccus entericus. The juices from salivary glands is salivary juice. The digestive juice from the salivary gland, salivary juice. That from the gastric gland, gastric juice. That from the pancreas, pancreatic juice. That from the liver, bile juice. And that from the intestine is the intestinal glands. That is, the crypts of Lieberkuhn and Brunner glands are of intestinal juice. That from the liver, bile juice, which is an enzymeless. And the pancreatic juice from the pancreas. From stomach, gastric juice, and from the salivary gland, salivary juice. We have discussed that the salivary glands, 4 pairs of the salivary glands are present among the mammals, but in human beings there are 3 pairs of the salivary glands: parotid, submandibular or submaxillary, and the sublingual. The salivary juice, which is slightly acidic, whose pH value is 6.8. And it's a component. So as a part of the table explanation, juice pH value and its a components. So the components are salivary amylase or ptyalin, mucus, thiocyanate, lysozyme and enzyme is the composition of salivary juice. Salivary juice pH 6.8, salivary amylase or ptyalin, sodium isothiocyanate, thiocyanate antibacterial, lysozyme antibacterial, and it is with the mucus and other salts. Electrolytes, we say sodium, potassium, and the chlorine are the salts present. Next, the gastric juice. Gastric juice is highly acidic. It is an acidic. This is slightly acidic. This is highly acidic, which vary from 0.9 to 1.8, or it is also, it is said to be the 1.5 to 2.5. It is all what because of the HCl, and it's is 0.9 to 1.8 or else 1.5 to 2.5, which is the same the in between. And this gastric juice, which includes the inactive pepsinogen and prorenin, which are converted into active pepsin and renin, and it is also with the HCl, which is an enzyme activator which kills the bacteria. And the next is it is also with the caseal intrinsic factor, which is for the absorption of cyanocobalamin or vitamin B12 and mucus. The third one is the pancreatic juice. Pancreatic juice is with the pH value 8.4, alkaline in condition, and this is with the trypsinogen, chymotrypsinogen, procarboxypeptidase in active form, which are converted into trypsin, chymotrypsin, and carboxypeptidase. It is with the lipase, pancreatic lipase is steopsin. It is with the also nucleases, DNAs and RNAs. It is with the carbohydrate digesting also. So protein, carbohydrate, fat, and the nucleic acid digesting enzymes. Pancreatic juice. Next, bile juice, an enzymeless secretion whose pH value varies from it is a 7.8, and generally the bile juice is of an enzymeless with bile salts and bile pigments, sodium, potassium, taurocolate and glycocolate, which play a vital role in emulsification. However, This is without the enzyme but play a role in digestion, that is digestion of fats, emulsification. And bilirubin, biliverdin, those are the components. Next, intestinal juice, which is around 7.6, and it is alkaline in nature. Basically, intestinal juice, Saccus entericus, it is the combination of the secretions of crypts of liver, Kuhn, and the Brunner's glands. It is with the enterokinase, the components of it, enterokinase, disaccharidases, maltase, sucrase, lactase, and it is with the aminopeptidase, dipeptidase, tripeptidase, nucleotidases, and nucleosidases. So this is a diagrammatic or tabular form of all the juices we see. Juice, pH value and its a component. Next, we'll go to the discussion of the digestion. Digestion is considered to be the hydrolysis process. Basically, the digestion involves digestion is considered to be the conversion of complex non-diffusible substances into simpler diffusible or absorbable substances is named to be the digestion. But chemically we say it is a hydrolysis process. Why? What we take the food is carbohydrates, proteins, fats. These are what are the macromolecules and are made up of the polymers. Basically, the polymers are combination of monomers. The bonds that are formed in this complex substances name it to be the carbohydrates. Next, the proteins, fats are all what with the macromolecules containing what is called it is with the bonds name it to be the polymers, which are a combination of monomers, and they are formed by they are with the bonds name it to be the anhydro bonds. The bonds that are the bonds that are present in between this collection of the monomers forming the polymers of these macromolecules is anhydro bond. That is the bonds that are formed by the removal of water. That's what we say, it's a anhydro bonds. The macromolecules called carbohydrates, proteins, fats are with they are said to be the polymers. They are with the polymers and have the combination of the monomers. These bonds that are present in these macromolecules are said to be the anhydro bonds, the bonds that are formed by the removal of water. So, in order to break those polymers, it requires the water, which means in presence of the water, the enzymes break down these complex substances into simpler substances. The bonds that are formed is anhydro bond, which are formed by the removal of water, are broken down into simpler substances in presence of water. In presence of water, the enzyme break down the carbohydrates or polysaccharides into the monosaccharides, proteins into amino acids, fat into fatty acids and glycerol. That's what in presence of water, the enzymes break down the complex bonds in the carbohydrates, proteins into fats, into simpler substances. That's what the digestion chemical is a hydrolysis process, hydro-water lysis breakdown. And that's the reason why the enzymes are said to be the hydrolysis. The hydrolases or what's it to be the carbohydrates. Carbohydrates. The ases is a term we add to the food substances. Carbohydrates act upon the carbohydrates. Proteinases or proteases on proteins. Fats, lipids, lipases. Nucleic acids, nucleases. This is how the hydrolysis involving hydrolysis enzymes are present. Name it to be the carbohydrates, proteinases, lipases, nucleases. Carbohydrates in the sense the starch. Carbohydrates are what is called polysaccharides. So carbohydrates is amylase. Next, these polysaccharides are converted into disaccharides by amylase. Starch or carbohydrates converted into disaccharides, name it to be the maltose, sucrose and lactose. So maltose, sucrose, lactose, upon which maltase, sucrase, lactase act, they are what name it to be the disaccharidases. The enzyme act upon the disaccharides is a disaccharidases, maltase, sucrase, lactase. They convert the disaccharides into monosaccharides. Simple sugars, glucose, fructose and galactose. So carbohydrates are polysaccharides by action of amylase converted into disaccharides called maltose, sucrose, lactose. By the action of the disaccharidases, the converted into disaccharides converted into by the action of disaccharidases, the disaccharides converted into monosaccharides called the glucose, fructose and galactose. That is carbohydrates. Next, protein digesting enzymes are proteases or proteinases. The protein digesting enzymes are the initially in the stomach pepsin, trypsin, chymotrypsin, carboxypeptidase, aminopeptidase, tripeptidase, dipeptidase. These are all what acting upon the proteins. So these are all what list of the proteinases which convert the proteins into amino acids. Next, lipases, lipids. Lipids are the complex substances. They are water insoluble. Fats are water insoluble. That's the reason why the digested food fats are what transported partly digested via the lymph. That is, we discuss it under the absorption. So fats are the lipids. Lipid digesting or lipases, which convert the fats into fatty acids and glycerol. This is how the digestion is a hydrolysis process. As in presence of the water, the anhydro bonds are broken down by enzymes. So it is a hydrolysis process. Chemically digestion. Digestion is of three types: chemical by enzymes, mechanical by tooth and muscles, and one microbial, that is a microbial digestion. So in this connection, first of all, the digestion process involve the swallowing, deglutition. The process of taking in food from oral cavity into the pharynx and esophagus is named to be the deglutition. Deglutition is the process of taking, that is the forcing the food from the oral cavity from pharynx into the esophagus is named to be the what is called the deglutition or swallowing, taking in food. Basically this deglutition, digestion, before digestion we have to discuss the swallowing or deglutition. Deglutition involve the voluntary stage, pharyngeal stage under the esophageal stage. Esophageal stage. Generally, the deglutition or swallowing in the sense the process of taking in the food into the oral cavity, and it's once the food is taken into the oral cavity, from oral cavity it is pushed into the pharynx and esophagus. This deglutition or the swallowing is both the voluntary and it is the involuntary. Basically, this deglutition or swallowing is the coordination activity of the palate, tongue. It is a coordination activity of the palate, tongue, pharynx and esophagus. It is a coordination activity by palate, tongue, pharynx and esophagus. The first stage is voluntary stage. First of all, the tongue closes the mouth cavity, so the food from tongue is involved. Tongue is voluntary muscles. So once the tongue closes the mouth cavity, the food from the mouth oral cavity forced into the pharyngeal stage. Next, it is a voluntary. Then pharyngeal stage. Once the food reaches from the oral cavity into the pharynx, the palate closes the nostrils, that is nasopharynx is closed, and larynx closed by larynx also seized. So the food neither enter into the what is called the nasal chamber nor into the what is called the respiratory passes. So the option is to enter into the pharynx. From there it moves. That's what it is, a pharyngeal stage. So it is involuntary. While pharyngeal stage, for a while the breathing is stopped. Next, esophageal stage is also involuntary stage. It is also involuntary stage, but it is in an involuntary stage executed within 1 to 2 seconds, where the food is forced to move into the esophagus. So the larynx reopen and breathing process resume. That's what the deglutition or swallowing. Swallowing or deglutition is the forcing the food from the oral cavity into the what is called the pharynx and then into the esophagus is a swallowing or deglutition. It involves voluntary stage, pharyngeal stage and esophageal. Voluntary is a voluntary process, whereas pharyngeal and esophageal is involuntary. Next, the digestion in the oral cavity or buccal cavity. Basically, the oral cavity, once the food enters into the digestion begins with the oral cavity or buccal cavity. Generally, the food when taken into the mouth or oral cavity, it is added by the saliva. The tongue pulverizes the food and adds the saliva. So that is the food bolus. Basically, 3 types of the food we find. That in the oral cavity is a food bolus, that in the stomach is a chyme, and that in the intestine is a chyle. So first the food when enter into the buccal cavity which is added by the salivary juice. The salivary juice when added to the food, the tongue pulverizes, mixes with the saliva and forms the food bolus. Then the salivary juice we have discussed contain an carbohydrate enzyme, that is salivary amylase or ptyalin or the salivary amylase. 30% of the carbohydrates are digested in the what is called a buccal cavity. 30% of the starch. So what we come to know here? We come to know that our digestion process begins with the carbohydrate digestion. Is it right or not? As the salivary amylase or ptyalin act upon the carbohydrates. So carbohydrates are digested. Partly 30% of the starch are digested. So our digestion process begins in the oral cavity where the salivary amylase act upon the carbohydrates. So our digestion process begins with the carbohydrate digestion. Salivary amylase or ptyalin act upon the starch and convert it into starch. Is converted into the disaccharides or the dextrins. It is taking place. So at the pH 6.8, salivary amylase or the ptyalin what act upon the starch? 30% of the starch only digested. So partially digested. Food of the buccal cavity named to be the what is called the bolus. Generally, this partially digested food from the buccal cavity as a process of the swallowing it is moved, which is aided by the mucus also. The mucus that lines the what is called the tract allows the food flow. Salivary amylase absent in herbivorous animals, it is to be remained. Salivary amylase in herbivorous animals. So the partly digested food in the buccal cavity moves on through the esophagus into the stomach. There starts the digestion of the stomach in the digestion of the food in the stomach. The food, the partly digested food bolus from the oral cavity through the esophagus, pharynx and esophagus gradually move into the stomach, where the cardiac sphincter which prevents the deglutition. Once the food reaches into the stomach, in the stomach the digestion takes place. The digestion in the stomach is the topic. Now we move on to digestion in a stomach. Stomach is the part where the gastric juice is released. Gastric juice is highly acidic. The gastric juice which contain the HCl, pepsinogen, prorenin. So carbohydrates are digested earlier. So proteins are not digested. When food reaches into the stomach, it is expanded. The expansion of the stomach and protein content in the food what stimulates the pyloric part of the stomach to secrete the gastrin. The gastrin secreted what stimulate the gastric juice secretion. First, the action of the HCl once the food is added by the gastric juice. HCl functions we have seen. The HCl, causal intrinsic factor. Next, pepsinogen, prorenin, along with that of the mucus is the composition of the gastric juice. So we'll discuss one after the another all these functions. HCl is highly acidic. This HCl what play a role in killing the bacteria, kills the bacteria. So in generally what we are when we take the food, if that includes any microbes are what killed by means of the bacteria, killed by, that is the microbes are killed by HCl itself. First, killing the bacteria. Second is the HCl is for the conversion, that is inactive enzymes called the pepsinogen and prorenin are converting enzyme. It converts the inactive enzymes into active enzymes. It provides the acidity. Acidic nature is very, very important for the action of the pepsin. In the stomach, pepsin is the enzyme present which require the action. Next, even HCl is considered to be the regulation of the sphincter, the opening of the stomach, which is the pyloric sphincter. The opening is guarded by pyloric sphincter, whose opening and closing is what also stimulated by the HCl. So killing bacteria, conversion of the inactive enzymes into active enzymes, and the what is called the closing and opening. This is what the functions of the HCl. Next, when the food added by the gastric juice, first the pepsinogen. Pepsinogen is by the action of the HCl is converted into active pepsin. The point to remember, just now we have discussed, pepsin is a enzyme. Even it acts upon its own form, name it to be the pepsinogen. The pepsinogen of its inactive form of pepsin, in presence of the pepsin, converted into pepsin, which is named to be the autocatalysis. The pepsin that is activated act upon the proteins and convert into peptones and proteases. Apart from that, pepsin also act upon the calcium paracasinate. The information we have discussed that prorenin is an enzyme, an inactive enzyme. Prorenin, R-E-N-N-I-N. Remind you that renin spelling is same, but there is a variation. R-E-N-N-I-N is there, R-E-N-I-N is there. Here the digestive enzyme related to the digestive system is R-E-N-N-I-N, which is in the infants. It is in the form of the prorenin. This prorenin is converted into renin, R-E-N-N-I-N. This renin act upon the casein protein. Renin act upon the casein protein. Casein is a protein in the milk. This renin act upon the casein and convert it into paracasin. In presence of calcium ions, furtherly, the paracasin, by the action of the calcium ion, what converts into calcium paracasinate, that is curdling of milk. We do see the infant when giving the milk, after within a short span of time, if they omit, it is of like a curd like. How? That is the role of the renin. Why? That is, the casein is in presence of the renin enzyme, it is converted into paracasin, and calcium ions convert in presence of that, it is calcium paracasinate, which is like a crystal. That's what it is very, very needed. Why? Upon calcium paracasinate, upon which the pepsin act and converted into the furtherly peptones and proteases, which are furtherly later on in intestine furtherly break down. So renin role in infants prevention of the milk from stomach into intestine. If as it is they enter from the stomach into intestine as their original form, it is sent out. So no sources of the energy for the children. That's the reason why renin present in the infant and act upon the casein, convert into paracasin, then in presence of calcium ions into calcium paracasinate. Upon that, the pepsin act and converted into what is called peptones and proteases. The same way in adults also, pepsin act upon the food stored for 4 to 5 hours in stomach. Meanwhile, all this process takes place. The pepsin act upon the proteins of native and convert them into peptones and proteases. In the same way, pepsin also act upon calcium paracasinate. This is how the completely proteins partially, not completely, partially the proteins are digested, whose complete digestion takes place in the intestine by the proteases called the trypsin, chymotrypsin, and the carboxypeptidase, aminopeptidase, tripeptidase, dipeptidase. So complete digestion in the intestine, partially digestion here. The partially digested proteins, acidic food is named to be the chyme, which furtherly undergo the digestion. Basically, the pepsin even digests the collagen protein, but it does not digest the hair, claw, which contain keratin protein. That's the reason why we say that the nails tearing is not good for our health. Even the hair, why, which contain the keratin, which is not digested. Pepsin does not digest, so it is an obstruction in the body.